So welcome everyone to Speckle's Community Stand-Up, and of course, Happy New Year. This is the first session of the year. For those of you who are new to these sessions, they are very short and sweet, 1 hour gathering with me, the amazing Specklers, and what we do is cover one topic. So today we have a very focused agenda. We'll do a quick and short intro, give you some updates on the product and the team, and then we'll cover what's going to be released in a couple of days, and that's Speckle 2.18. And then the main focus, as the name shows already, it's Grasshopper. So Bilal will demo a very relevant workflow, which is Revit, Grasshopper, and Power BI. And of course, we'll leave some time for questions and tell you what's coming next. So let's start with a few updates. Unfortunately, Benjamin isn't here today, but we wanted to welcome him to the team. He joined a few months ago and is joining the web team as product lead. So he's essentially leading all the initiatives around the new front end, and you'll probably see him in the next stand-up. What's also, as most of you should already know by now, but we're opening a form for our closed beta. And this is essentially Automate, which is a big announcement that occurred at SpeckleCon in November last year. And so if you're curious to learn more, I will share a link in the chat so that you can join and sign up to the closed beta testing group. And just a short, sweet reminder that if you have any questions, please post them in the Q&A so we can keep track of what you guys are interested in and make sure that we answer and cover all of your questions. So without further ado, I'm going to let Bilal tell you more about the release. And
all right, thank you, Sanda. Hey, everyone. So Speckle 2.18 is coming very, very soon, hopefully. We are working on the Rhino 8 connector support. Hopefully, it will be part of the 2.18 release. Then we're also going to release some ArchiCAD related features too, such as the ArchiCAD 27 support and support for the Mac installers for both Intel and silicon-based Macs. And yeah, we have also added some new, we have made some improvements on the families from your SketchUp components, and also convert your components into existing Revit families. We've also added tag supports in Grasshopper connector. For Civil 3D, we've expanded our support for properties. We've included name and alignment. And there are also more bug fixes, feature improvements, and so on. So stay tuned on the Speckle community if you are interested in what is coming in Speckle 2.18. So today, our main focus is going to be using Grasshopper to make your Revit data leaner for Power BI, right? We're going to use Grasshopper as the main authoring application, but our goal is going to be making our Revit data more lightweight and more relevant for Power BI workflows. You may ask why? Because we had some reports from the community about receive times being too long and visual not being able to visualize all the data within Power BI, and there are reasons for those, right? The first one is your Revit model contains a significant amount of information, and not all those information might be relevant for Power BI, right? And the second one is the data structure within Revit is highly intricate, right? Everything is so complex. For instance, like parameters are not simple key value pairs. They also contain a bunch of data and so on. So your data structures might becomes really, really complex. And extracting the relevant information within the Power BI's interface might be a bit time consuming and tricky if you're not a Power Query expert. So Grasshopper, in this case, might be a middleman, right? Since the visual programming environment is much more flexible and so on. So we can use Grasshopper as the middleman to make the Revit data more relevant. And lastly, receive times can be long because you're receiving your whole data from Revit, and it is probably going to contain a lot of data that you're not particularly interested in, right? But receiving all those data still takes a lot of time. So we're going to use Grasshopper to clean it up, only filter the relevant information, send it to Speckle, receive it in Power BI, and hopefully create a dashboard. And I also wanted to add a small meme here. So the one on the left is your current Revit data. And hopefully at the end of this session, we're going to filter it so it's going to be much more lightweight and more relevant. So how are we going to do that? First, we're going to receive our Revit data in Grasshopper, filter out what we need. I'm going to explain the example scenario in the coming slides. Create some Speckle objects, send it to Speckle, and at the end, hopefully receive it in Power BI to create a dashboard. So to follow this session, you need 4 things. The first one is obviously a Speckle account. If you already don't have it, go to app.speckle.systems, which is our new web application address. Go there, create a free account. And then, as I said, we're going to use 3 applications, Revit, Rhino, and Power BI connectors. You need to install those. Revit and Rhino connectors are installed via Speckle Manager. And Rhino connectors comes bundled with Grasshopper, which what we're interested in. So if you install Rhino connector, it will also install the Grasshopper connector. And lastly, we're going to install the Power BI connector, and you can download it from the GitHub repo. I hope Sandra will share the links in the chat in a minute. So what is the example scenario? We have this structural model, which is more of a mid-sized, but in your case, this might be a tower project or maybe like a huge city hospital project or something. It can be much more big in terms of file size and so on. But just to make this demo go faster, we wanted to keep it in a mid-sized model. And we're only going to extract the following parameters, right? The geometry information from my Revit model with materials intact. We're going to extract the family, type, level, and volume parameters too. And hopefully this is going to be the Grasshopper script we're going to create. And at the end, we're going to end up with this Power BI dashboard. And the difference between receiving the Revit data directly within Power BI and filtering it via a Grasshopper step is basically, if you filter it, it's going to become much more lightweight, right? Because you're going to get rid of all the junk data you don't really need, and your receive times will be faster, and your dashboard will be much more interactable. So I'm going to do a live demo, and pray to demo gods nothing crashes. Let's go my entire screen and share. And oops, let me see if I can open Revit. Can you see my Revit? Can anyone confirm? I can't see you guys.
We can see it.
All right, perfect. So this is the Revit model that I'm going to use. And I already created a containers inside Speckle, a model, a placeholder model to send the data to. So I'm going to select that. I created it inside Community StandUp and Revit. And again, instead of sending everything from Revit, I will do a pre-filtering on the Revit side first. So instead of sending everything, which includes all the levels and types and so on, I will only send select categories. So first, this model consists of walls. I will select walls, floors, some structural columns, foundations, and framing. So these are the categories that I have in this model. So I will click on send. And what it does is it converts these Revit elements into their Speckle equivalent so they can be received inside Grasshopper. And let me quickly open my other window where I have my model here. And I can also view it in here. So once you start screen sharing, for whatever reason, your internet speed becomes much more slower. But anyway, so this is our Revit model, right? These are Revit floors, Revit columns, Revit beams, and foundations, and so on. So I'm going to copy the link and go to Grasshopper now and open a Grasshopper script. So I'm going to make this full screen and go over some of the nodes that we're going to use. So I'm going to use the receive node from the Speckle package to receive data from Speckle. Simple as that. We're also going to use a Speckle object value by key node, right? So Speckle objects, you can think of them as basically dictionaries. And this node allows you to get the value of a specific key you are looking for. We're going to use this a lot to make the script much more readable. And then we're also going to use the deconstruct Speckle object node to understand the structure of the data. We are going to extend Speckle object, and you will understand what I mean by that. But essentially, as its name suggests, we are going to be able to add additional fields to the Speckle objects using this node. We are going to create our own Speckle objects using the create Speckle object node. I will also use the Python script to show you some tips and tricks to how to simplify the parameter value extraction. And lastly, we're going to use the send node to send our data to Speckle. Simple as that. So let's start with the receive. I'm simply going to type in receive, and this expects a stream, and we can paste the URL we just copied as the stream input and press receive. This will now fetch the data from Speckle and load it into the Grasshopper environment. And here it is, right? This is the received data. I'm also going to connect a panel and connect it to the elements output, and we can see 5 collections here. So you can think of collections as a collection of element, basically. In this case, they are corresponding to Revit categories. So each category has its own collections. And in this case, we want to get the elements inside those collections, in the individual elements, the walls, floors, etc. And we are going to use the deconstruct Speckle object node, DSO, for that. I'm also going to connect the elements as the elements output, and here it is. We can see the structure of this collection now. And now if I connect another panel into the elements output, we can see the individual walls, beams, columns, and so on, right? So as I said, first we are going to extract the geometry of all the elements. So let's use the deconstruct Speckle object node, DSO again, to see how the objects are structured. And I'm going to do zoom extend all, so we can see the preview of the geometry of the received data, right? And this geometry of, for instance, the Revit column, Revit floor, the foundation beam, etc., they are stored in a key, in a field called display value, right? This display value contains the mesh representation of the column object. So we want to use that to extract the geometry. So I'm going to drag and drop this into here. And instead of using this huge deconstruct Speckle object node, I'm going to use object value by key. Speckle object value by key node. My elements is the object input. And the key I am looking for is this one, display value right here. It's connected as the key input. And now I have my mesh geometry here. And if I connect a panel to it now, you can see these are converted into Grasshopper meshes now. So let's actually send this into Speckle now first, and then I will explain the next step we're going to do. So this is the geometrical representation. We're going to send this into Speckle, and we are going to send this into the Grasshopper container, I guess. I will paste this into a panel, connect, and send. And now these are being, converted and uploaded into Speckle, and it is sent. Let me open this in a new view and put it side by side with this one. And hopefully refresh the Revit one so it looks a bit better. Yes. So as you can see, my Revit model, the one that I sent from Revit, is light gray. And this one is dark gray, right? This is a structural model, so maybe the shade of the gray is not really that relevant for you. But the thing is, the one that we have on the right-hand side does not have any material applied to it. That's why it looks dark gray. Maybe for a structural model, this may not be a big issue, but when it comes to architectural model, materials are a big deal. So we need to preserve the materials applied to each mesh too. So let's go back to Grasshopper now and add material to our meshes. Right, I will move this out of the way, and I will copy paste this display value one more time. So this one is the mesh representation, right? And as I said, these are now converted into Grasshopper meshes, and there's a text here using the objects converter. So what this means is, these were previously Speckle meshes, but now they are being converted into Grasshopper meshes. And Grasshopper meshes does not have a material applied to them. That's why they look as the default color. So I have duplicated it right here. So we have the mesh representation. But in this one, I don't want to convert it into a Grasshopper mesh. If I were to connect the panel to it now, these are still Speckle meshes. And the beautiful thing about this is now if I were to connect a deconstruct Speckle object node, I can see their material right here. If I were to connect a deconstruct Speckle object node to this one, you won't see any rendered material in Grasshopper meshes. So that's why we don't want to use the objects conversion if you are interested in getting the material. All right, so now let's extend this mesh objects with the material key, so they also have the material applied. Again, I will use the extend Speckle object node. My Speckle object will be the mesh, and I want to extend this with the render material key, which is not going to be detached. And then I will connect my render material as the material input, and hopefully I should have 1255 elements, and connect this as the data input and send again. It is sent, and voila. Now these meshes, they also have their corresponding materials. So we are keeping materials intact. That's great. So we have done the first step, which was the extracting the geometry, so we can use it inside Power BI in the 3D Viewer visual, so we can have that kind of like an interactive dashboard kind of thing, while still preserving the materials, so it looks great on the Power BI side. All right, I'm gonna close this. Let's go back to Rhino and continue with the next step, which is going to be extracting the family, type, level, and volume parameters. So we already have this node here, and I can see the family parameter is stored in family key, and the type parameter is stored in the type key. So I can easily extract them using the object value by key node, like so. I will say this one will become a family. This one will become a type. And hopefully, here are all the families in my model and all the types too. As simple as that. Let's continue with the level extraction. So I will do that here and say this is going to be my level. If I connect a panel to this now, you're going to see this is another Speckle object. And this comes to my second point, which was Revit objects are highly intricate, right? The Revit level parameter is not a simple parameter name, the level name value. It is a level object in itself. It can have a bunch of parameters. So we need to deconstruct this too. I'm going to use again deconstruct Speckle object, see to find the field that I'm interested in, which is, I guess, the name field, right? Right here, we are interested in the name. I can use the deconstruct Speckle object node, or I can copy paste this one, connect my level objects as the input, and change the key I'm looking for into name. And now I have all the level names listed here, 1255 elements. Nice. So the last thing that I'm interested in is the volume parameter. And I don't see a volume parameter in the top level of my object. And that's normal because not every parameter, is a top level parameter. And all the, Revit parameters are stored under a key called parameters, as its name suggests. So I'm going to deconstruct that as well to see what it has in it. And it has this huge list of parameters from the element type to door number to what? There's some structural parameters and so on. But what we are interested in is called host volume computed. And this parameter itself is another object, so we need to deconstruct this too. Host volume computed. And then we are interested in the value, right, which stores the volume that we're looking for. And as you can see, this can become quite messy quite fast. But deconstruct Speckle object node is great for investigating and understanding the structure of the received data. You don't necessarily have to use it. And I'm actually going to show you a trick now, or a tip, that you can use Python node, the default Grasshopper Python node, to get what you want. As I said, Speckle object, you can think of them as dictionaries. And in this case, what we are actually looking for is, from all these elements, we are looking for the parameters. And from the parameters, we are looking for host volume computed. And from there, we are trying to access their value. So let's do that using the Python node. I'm going to add a Python node here. Get rid of this one, rename this to maybe element, and we are trying to access to volume. I'm going to get into this and then simply say, volume equals to, from element, get their parameters. From parameters, get the host underscore volume underscore computed. And from there, get its value. OK. And then connect element as the element input. And let's connect a panel to here, see what's going on. And ta-da. So instead of this, you can have this and get the same value. So I think this is, a really, really powerful way of accessing your data within Grasshopper. So we are nearly ready, right? We have extracted the geometry with the materials intact. We have the family parameter, type parameter, volume parameter, and lastly, also the level parameters. So now let's combine all these information to create our own Speckle object structure using the create Speckle object node. Shortcut for that is CSO, as far as I remember. Here it is. We can add some arbitrary inputs like so. And then we can say, my geometrical representation for this object is going to be stored under display value field. And then I will add maybe the family. And let's actually not detach this. You don't have to detach, strings, integers, and so on. The other one is type. Next is going to be level. And lastly, it's going to be volume, right? And let's take a look at the structure of our data. So we have 5 branches here. This is going to be the volume inputs. This is going to be the level inputs. This one also has 5 branches. This is going to be the type. This is going to be the family. And lastly, we're going to also connect the display value, but I think I need to trim this tree. I'm not a, Grasshopper guru. So you may say, flattening, trimming, they are bad practices. Okay, but I need to get the job done. So I'm just going to go with the dirty way of doing things. I'm going to trim this tree for maybe 2 levels. And hopefully it will align with the structure of the rest of the data. And yes. And I will connect this as the display value inputs, which will output the 1,255 Speckle objects with their geometry and parameter properties. So we are pretty much ready. Let's connect this as the data input and click on Send now. So what I've shown so far is basically, how to filter the geometry and how to attach your own property or your own metadata to your, Grasshopper objects. And it is here. And if I select this now, I can see its family, level, type parameter, volume, and its display value is also correct and so on. So perfect. Everything is ready. So now we can basically receive this. It's ready to receive in Power BI. So within Power BI, simply, search for Speckle, connect, and paste the URL and click OK. Let me turn on the light. It's getting late here, so sorry. And let's open the Power Query Editor to see the structure of our received data. And I'm going to select one of the base objects. And here are all the parameter values, the family, level, and so on. So let's add a new column. Let's name this family, and it is part of the data family. Click OK, and we will get a bunch of errors, and that's expected because the mesh object does not have a family field in it. So we can easily get rid of those errors by highlighting this and click on Remove Error. So rest of the objects, they have the family field in them, so they are valid. And lastly, let me expand the data column to get maybe what the type, the level, and volume parameters, and click OK. And ta-da! Right? It is much more tabular. And that is thanks to the pre-processing we have made on the Grasshopper side. You can do the same thing within Power BI too, by the way. But it's going to be much more complicated. And if you're not a Power Query guru or an expert, right, the data structure that is coming from Revit is going to be a bit messy on your side. So lastly, I will also change the data type of the volume to decimal, so we can do some, mathematical calculations in our dashboard. Let's load this back into our dashboard. It is loaded. I will also quickly import the 3D Viewer visual. Okay, let's add this. And this is how it looks like. And again, we can simply connect the relevant inputs to visualize the geometry. Stream URL, commit object ID, and object ID. And ta-da! So this was pretty fast, right? If this was a Revit model, and if this was like a bigger structure, then this would take a bit longer, because now we only have the geometry and the relevant information. The rest of the data is not there, so it's much more lightweight. And it's also ready to, create some, maybe, add other default Power BI visuals, like maybe tables. We can say, get maybe level, family, type, and lastly, maybe volume. We have something like this. And then let me actually make this a bit smaller. We can also add some cards into our dashboards, like so. And maybe get the sum of volume. So we can quickly see 1.64K is the total, maybe concrete volume that's going to be in this structure. We can also do maybe like a slicer kind of thing. Where is it? Like so. Right, we can edit into here. And maybe quickly try to filter elements by their levels. Or we can add like a tree map kind of thing, where we can put maybe families, and for volume, I guess I'll put the volume and type, like so. So we can maybe start interacting with our visual. So I will put maybe, let me select my visual and add, I don't know, the level inputs or volume. I'll put the volume into the tooltip data. So when I select an element, I can see its volume right here. And again, this is interactable, right? You can select any other visual in your canvas, and it will interact with your data inside Speckle, like so. I can quickly find the elements, their types, and so on. So that's it. We have done it. I hope you didn't get bored.
We're all still here, Bilal, don't worry.
Yes, thank God. I was a bit worried because I can't see anyone, right? I hope you were able to see and hear me and able to follow me. But yeah, the main benefit of this workflow is basically, making your data much more lightweight, much more ready for consuming on the Power BI side, because we had some reports from the community about, they are sending everything from Revit, and it's taking a while to receive that in Power BI, and that's expected, right? There isn't much we can do on that front until we add some additional filtering capabilities, both on send and receive side. We can go with the Grasshopper route, and I think this can also become maybe like a automate function in the future, hint. And yeah, over to you, Sanda.
I mean, you just answered one of the questions we had in the chat. So can this data cleanup be executed automatically with Automate? I guess that's a yes that you're giving there. Yeah, we have other questions that I'm just going to go through. Is it possible to use key1.key2.key3 in a panel connected to a Speckle object value by key component to dig into a nested Speckle object?
Like a Python way of doing things in a panel connected to Speckle object. I see.
Yeah,
Alan?
like in C# or something, or the way that you now chain these strings inside square brackets inside the Python component. This just came to mind. I thought maybe it's possible. It also works like that in headers of Excel, right?
Yeah, we didn't like the key Speckle object value by key only searches the key of the top level object. We didn't add any syntax for like deep level nesting. Mostly because it gets complicated when you add lists to the equation, and you suddenly need to invent a whole new syntax that is readily available in Python. No, so we just decided to not reinvent the wheel. And if you need like deep nesting of a specific deep fetching of a specific property, the pure Python node with like 2 lines of simple Python would do the trick way better than we would ever be able to allow you on our end.
Yeah, that's perfect. It was just out of curiosity, not the feature request at all.
You're not the first to request this.
No, it's not
at
a
least
feature
little
request.
we can
It's just like curious how it works.
Yeah.
And thanks.
You're welcome.
And so, yeah, I don't know if you want to go through your other question. I can read it for you. Is it already possible to use the Power BI Speckle viewer on streams that are not public?
Right now, no. It's on our roadmap. We know that people want to receive privates. People want to view private models inside Power BI. It's on our roadmap. Hopefully, we'll be able to add it, but as of today, no, it is not.
And then if I were to export Speckle data from multiple projects into a single SQL Server database, what process would you recommend?
Who can answer this? Maybe Matteo or Alan? Putting you on the spot again. Do you have any idea?
I guess it would depend on what you want to do with it. No, technically, Speckle is already storing the objects in the server in an SQL database for you. So I guess it would depend on your use case. Technically, we provide ways of doing that on the code level, but I'm not sure it's something we want to heavily recommend. Maybe somebody on the web team has some extra insight.
I guess they don't.
Sorry, I was on mute. I would really need to know more about your use case to recommend a path forward, because this can be a loaded question. So if you want to describe your use case to me, Santiago, please do so in the forum, and then we can discuss.
All right, those were the questions we had in the chat, but if anyone has more questions, please feel free to jump in, unmute. This is an open forum, so. And in the same time, I'll post some resources to Power BI. So we had our last year's community stand-up on specific workflow on Power BI, and we have a few tutorials as well if you want to upskill your game. And if there are no more questions, we can just go to the next slide. And this is more of a small request from our end, but we are currently preparing for the launch of our new front end, new web interface. And so we're gathering some user interviews and user insights. So if any of you are interested in joining the conversation, I'll post a link in the chat, which is essentially a form, which will take you 2 seconds to fill in if you're interested in joining us to discuss feedback and any other things related to the front end. And finally, we will be having our next community stand-up end of February, so a month from now. And this one will focus on the new front end. So as you already know, there's a bunch of updates, lots of improvements coming, and we're very, very excited to share them with you. So mark the date in your calendar, and we will hopefully see you very soon. And that's it from us. Thank you for listening. Oh, we have a few. I don't know if it's claps or people who want to.
I feel like it was a clap, but
Okay.
Google Meet confusing people.
Well, yeah, thanks for joining. See you in a month. Bye.
Bye, everyone.
See you.